go ahead and welcome. Let's go ahead and turn on the volume. How does that sound? So what I want to do is show you how to find the zeros of a polynomial. And what we're going to do is we're going to use a little technology, but also I'm going to kind of show you a way, first of all, just to kind of narrow that down, working with this. So what I'm going to do is I'm going to use the rational zero test to help us narrow it down. Then we're going to use technology to even narrow down even further more the zeros. Because remember, finding the zeros, right? So far we've worked on factoring techniques. We've worked on completing the square to find the zeros. But that was really about it. Quadratic formula as well. But once we get now to higher order polynomials, a lot of factoring skills are not going to work. So far as the quadratic formula or completing the squares, those are made for the when you have a quadratic type polynomial. So for higher order polynomials, we need to come up with a couple other tests. And there's a couple other. I'm just going to focus on the rational zero test for today. So the rational zero test tells us that all the possible rational zeros are in the form of the factors of p, which is your constant, over the factors of q, which is your leading coefficient. So that means I'm going to have plus or minus 27, plus or minus 9, plus or minus 3, and plus or minus 1. All right, and these are all over the coefficients of 1, which are the leading, or the factors of 1, which we obviously know are just going to be 1. So therefore, we're going to leave us as whole numbers. So now the next thing, so what I have currently is 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 possible factors. And ladies and gentlemen, to show that one of these are going to be 0, there's a couple ways you could do this. You could use the remainder theorem. We could plug in each one of these zeros into our function, and if we get a value of 0 for p of x, then we know we have a 0. We could also use synthetic division for all of these, and once we use synthetic division for all of these, we could determine what's our remaining zeros. And what we could do is remaining zeros, right, by using synthetic division, correct, and that would help us out. But to do that, you're going to have to do synthetic division of 8 polynomials. And that's kind of long. It's really not that bad, but it could get a little tiresome, especially if you're taking a test. So what we're going to do is we're going to use technology. Now, I already looked at the graph. And what I did was I used a graphing calculator, and I already checked out the graph. And it looks like to me what I have is we have a 0 at 3. So what I'm going to do is I'm going to check that. So whenever I see my calculator, even though I can use my function on my calculator to verify it's the 0, I need to verify algebraically that 3 is going to be a 0. So to do that, I am going to use synthetic division. And I'm going to use synthetic division rather than the remainder theorem, because what I want to do is I want to get the remaining polynomial so if I can see what other zeros I can create. So bring it down. 1 times 3 is 3. Negative 6. Negative 6 times 3 is negative 24. Bring down the 3. Looks like we have 3 times 3 is going to be 9. So therefore, I'm going to have a remainder. Let's double check my work. That becomes negative 6. Negative 3 is going to definitely be an 18. Wow. Which will give me a positive 9, which gives me 27. At least I caught my work, right? Which is a remainder of 0. So you could say, all right, well, 3 is going to be a factor. Now, let's go and look at what we have. So that's my remainder, right? Since it divides evenly, it's my remainder. So then left, I have x squared minus 6x plus 9. So I look at my factor and say, all right, can I factor this any further? And yes, actually, you can. You can factor this further. This now factored down becomes x minus 3 squared. So ladies and gentlemen, what we've just created here, so now I could say my factors are x minus 3 squared times x minus 3. So therefore, really my factors are x minus 3 cubed. So if I want to find the zeros, my only 0 is going to be when x equals positive 3, right? Because remember your factor, you set equal to 0. So my 0 is going to be x equal 3, but I'm going to have it a multiplicity of 3. But since that multiplicity is odd, that's going to tell me my graph crosses at 3, which it looked like. I didn't get to zoom in, but the graph is going to cross when x equals 3. So there you go, ladies and gentlemen. That's how you find the zeros. I hope you enjoyed. Thanks.